All right, so let's go ahead and look at something like this. For decomposition of fractions with something that has a square of a repeated factor, we're going to have special case. So this works out pretty much the same, 24x plus 2. We're still going to factor the denominator, which actually there's a GCF, and then x squared plus 4x plus 4. And then that factors again as x. And then we got x plus 2. I'm going to put squared. It's actually x plus 2 times x plus 2. I'm condensing that to 1. If this ever happens, and it's called a repeated square. So you actually have to break this down in a special way. So 5x squared plus 24x plus 2 over x plus 2 squared. That is going to be a over x, which makes sense, right? Plus b over x plus 2, and then plus c. This is the weird part. It actually has to be x plus 2 squared. Okay? And the reason for that, you can think through, if you have x plus 2 and then x plus 2, well, what would be on top of which one? This one requires that you have a squared, first of all, to be able to get squared so that we can solve it. And second of all, you wouldn't know where b and c would go. So it's kind of weird, but it's just how you do these types of questions that have repeated values on the bottom. So let's go ahead and clear our fraction. If we multiply by x plus 2 quantity squared on top, we end up, or on the left, we end up with this. Okay, if we multiply on the left for a, we're just going to end up with a x plus 2 squared, right? Because the x cancels. For b, we end up with the x, and we end up with the x plus 2, another x plus 2, because the other x plus 2 would cancel. And then for c, we end up just with cx. All right. For this one, we can still do what we did with roots. I think that might be easiest right now. What number could we use to cancel out this guy? This guy right here, we could use x equals negative 2. Okay? So that would make that a cancel, and it would actually make b cancel. That's nice. So I can figure out what c is pretty fast. So 5 times negative 2 squared is 20, plus negative 48, because it'd be negative 2 times 24, plus 2. All right, and that equals c times negative 2, because a, this whole term cancels, this whole term cancels if I plug in negative 2. All right, I can solve for c. So that would be 20 plus 2 is 22, minus, what was that, 40, so 22, so 6, is that 26? Negative 26? Yes. All right, equals c times negative 2. If I divide both sides by negative 2, c ends up being 13. Not too bad. All right. I need to go a little further down. What if we plugged in, what would make this go away, the x go away? Well, that means if I plug in 0. Actually, that's super nice, because that will cancel out the b and the c, and it makes my life a little bit easier over here than the last one. So let's plug in 0. That gives us 2 equals, the only term left would be the a term. If I plug in 0, so x equals 0 is what I'm doing. If I plug in 0, I get 4 for my coefficient of the a. So a is equal to 1/2. Sweet. All right, now I just need to use, I guess I could just plug all of this in. Well, let's see. What would be the easy way to get to b? Oh, man.
Ms. Bowell, please report to C102. Ms. Bowell, please report to C102.
On my practice, we actually, well, no, I can do that. Yeah, I think that'll work. What is it that I can plug in to get that? Okay, so I'm going to do something a little bit tricky. I'm going to recognize that this right here is my coefficient of the x squared. The coefficient of the x squared over here is going to be a, because this will be x squared. Coefficient of b is going to be x squared as well. So I can actually say 5 must equal a plus b. because those will be my two coefficients of my x squared. It's kind of a hybrid of the other one, setting up the systems. That's the only way to get to that, to find out what b is. And so I have 5 equals 1/2 plus b. So if I subtract 1/2 from 5, I end up with b equaling 9/2 or 4.5. So for my final answer, 1/2 over x plus 9/2 over x plus 2 plus c, which is 13, over, where was I? X plus 2 squared. In retrospect, for this problem, I probably should have used my grouping way, like where I'd multiply everything out and combine everybody that's got an x squared together like I did on the last. Because you can solve for A, you can solve for C, but B was a little tricky. I had to do a little bit of that other process to get what B was. But why in the world? Why do we have to do this? Well, here's a proof. If you want to pause the video, you can read this amazing proof of why we have to do that for repeated factors. And you can pause the video and look at that. That's all I got for today. Thank you so much for listening, and I will see you next time.